Hello, welcome back to Cinderella Math. Today I'll be finding the equation of the tangent line. This is a topic that comes up in Calculus 1. So if you're working through Calculus 1 right now, I got you. So I am using a paper that one of my tutoring students sent in to me. It looks like it's from CUDA software if I had to put some money on it. But teachers can manipulate CUDA a little bit. So you might have this exact sheet, but if not, these are still some good examples of how to find the tangent line. I'm actually going to skip those top two, the number 33 and number 34. In my opinion, those are the hardest, so we're going to come back to those. I'm going to start, please, with number 35. All right, so when you see the directions, find either the slope of the tangent line or find the equation of the tangent line. You want to go ahead and take the derivative. So that is why this is being taught in calculus, because it needs the derivative. So looking at 35, I'm going to rewrite that real fast as negative 1/2, because there's a 1 there, x squared minus 1x plus 11/2. If you don't need to rewrite it, feel free not to. Now I'm going to take the derivative using power rule. We multiply, so that would be negative 1, subtract 1, so that would just be x. We multiply, so that would be negative 1, subtract 1, so that would be 0. So he's gone, and the derivative of a constant is nothing. So there's our derivative. You could, of course, cut that coefficient and just say negative x minus 1 is our derivative. Now, to find the slope of the tangent line, plug your x value in, and that's given to you at the tip top. You're given a point, x, y, put the x value into the derivative. So you're basically doing y prime evaluated at negative 2. So that's going to be negative 2 minus 1. That's 2 minus 1, so 1. This is our slope, our m value. So if the question is just find the slope of the tangent line, you're done. You would say 1 and you'd walk away. We want the equation, and the directions on this paper did say in slope-intercept form. So we're going to say y equals mx plus b. Use the given point. This is x, this is y. So 11/2 equals slope, which is 1, times x, which is negative 2, plus b. So 11/2 is negative 2 plus b. Negative 2 we're going to rewrite as negative 4/2. We're going to add 4/2. And we get 15/2 is b. So final answer, y equals mx plus b. Yes, of course, you could ghost off the 1 and just say x plus 15/2. That should be fine. Okay. I will not go to Desmos to check every single one of these, but I'll do it for a couple. So since this is the first one, you might be saying, could I check this? Yes, you can. So what you're going to do is type the original function into Desmos. So let me just pull that paper up on my phone here. That was negative x squared over 2 minus x plus 11/2. And then you're going to type the point of interest, which was negative 2 comma 11/2. I'll zoom this puppy out. There we go. So that's the original function, and the blue dot right there, there's our point of interest. What did we get for the equation of the tangent line? We got y equals 1x, or just x, plus 15/2. This should hit the point, boom, and it should hit just at the point. We have done it. That is how you can check. So it's not going to say like, yes, you're right, no, you're wrong. You're just going to visually check that you have found that tangent line at that one point of interest. Okay, again, you don't have to do that, but if you want to check, by all means, that's how you would. Okay, that was 35. I'm coming to 36, which is probably the easiest on the page, so maybe I should have started there, but it's fine. All right. Take your derivative, which would just be 2x, because derivative of negative 3 is nothing. To get the slope, we're going to do the derivative evaluated at x value. This is x, this is y. So at 1. So that would be 2 times 1. Our slope is 2. If they just said slope of tangent line, you're done. But they want the equation. So y equals mx plus b. So that's negative 2 equals 2 times 1 plus b. Negative 2 is 2 plus b minus 2. Negative 4 is b. Final answer, y equals slope, so mx plus b, but doesn't that look clunky? From your algebra class, we know plus a minus is just a minus, or plus a negative is just a minus. And again, x squared minus 3, 1, negative 2. I'm coming over here to check. X squared minus 3. We care about the point 1, negative 2. And we got, I don't remember the answer, 2x minus 4. Boom, looks good. Alrighty. Coming to this number 37. There's your function. There's your point of interest. Take the derivative using just good old power rule. So this would be 3x squared minus 6x. Find the slope by doing y prime evaluated at the x value, which is 1 in this problem. So that's 3 times 1 squared minus 6 times 1. So that's 3 times 1 minus 6 times 1. 3 minus 6 is negative 3. There's our slope. Okay. Y equals mx plus b. So we have 4 equals negative 3 times 1 plus b. 4 is negative 3 plus b. Add 3. 7 is b. Y equals mx plus b. Answer. Hey, I know I'm going a little fast. Feel free to slow me down with the speed here on YouTube. Pause me. Coming to 38. I don't think I'll check that one. Feel pretty good on that one. 38, just straight up take the derivative. I'm going to scratch that one off so we know we're not looking at that. Looking at this one. Taking the derivative would be 3x squared minus 22x plus 39. Getting the slope, we're going to do y prime evaluated at 2. So that's 3 times 2 squared minus 22 times 2 plus 39. Of course, you can just use calculator if that's allowed. That would be 3 times 4 minus 44 plus 39. 12 minus 44 plus 39. Let's see, it's getting late here. 12 minus 44 is negative 32 plus 39. I'm getting 7. That's our slope. Let me check that though, because it's getting a little late. Yeah. So if it just said slope of the tangent line, you would say 7, but they want the equation. So we go into y equals mx plus b. Looks like our x is 2, y is negative 7. All right, so negative 7 is 14 plus b, minus 14, negative 21 is b. Answer, y equals mx plus b, but again, this looks bad. Plus a negative is just minus. Okay, I'll check that one real fast. Just because it looks a little big, but that doesn't mean it's wrong. Right. 7x minus 21. I'm going to go ahead and just put on the answer. It's fine. There's the answer. The point of interest was 2, negative 7. And the actual problem, I'll just grab my phone for this part. This is 38. It was x cubed minus 11x squared plus 39x minus 49. All right. Yep, that looks fine. Looks like that's tangent to the point of interest. Yep. Okay. Coming down to 39 and 40. So 39, just very similar to the one we just did. Let's do the derivative. Negative 3x squared plus 4x would be our derivative. And now let's do that derivative evaluated at 2, our x value. Plug it in the calculator or by hand. I'm getting negative 4 for our slope. Y equals mx plus b. Here's our x, there's our y. 3 equals negative 4 times 2 plus b. There's negative 8 plus b. Add 8. 11 is b. Y equals negative, excuse me, slope, so m, negative 4x plus 11. I don't think I need to check that one. I think it's fine. Feel free to check it if you'd like. That was 39. I'm gonna scratch that one off, going to 40. This one is gonna require a little bit more work to do the derivative because we need to do the chain rule. So this is 40, y prime. You will drop this down, keep what's in the parenthesis, subtract 1, so that's 2/3 minus a whole pizza, which is 3/3, so that'd be negative third. And then times chain rule derivative of the parenthesis. So derivative of 2x plus 4 would just be 2. And then let's clean this up. 2/3 times 2. 2/3 times 2 is 4/3. Okay. So we have 4/3 and then that parenthesis stuff to the negative 1/3. And then let's clean it up by sending the negative power downstairs. So we have 4 over 3. You can split the fraction like that. And then this would be 2x plus 4 to the third positive once he comes downstairs. Or you might have learned in pre-calc or even algebra 2 that a third power is a cube root. You can do it either way. It doesn't matter. So there's our derivative. Let's get our slope. So we're going to do that derivative, y prime, evaluated at our x value, which is 2. So that's going to be 4 over 3. 2 times 2 plus 4 to the third or to the cube root. So that's 4 over 3. 2 times 2 is 4. 4 plus 4 is 8 to the 1/3 or cube root 8. If you think about 8 real fast, that's 4 times 2, 2, 2. 8's got 3 2's. Cube root of 8, or 8 to the third, is 2. So this is going to be 4 over 3 times 2, 4 over 6, which reduces to 2/3. There is the slope of the tangent line. I'm going to erase stuff, so pause me if you're writing. Now to get the equation of the tangent line, y equals mx plus b. This is x, this is y. So we have 4 equals slope, which we just found to be 2/3. X is 2 plus b. So 4 equals, we already did 2/3 times 2. That was 4/3 plus b. 4 whole pizzas is 12/3, right? 12 divided 3, that's 4. If you have a fraction calculator, you don't really need to do that step, but I like to. This is why fractions were so important back in 5th grade. You knew they had a reason. There we go. Final answer, y equals 2/3 x, so mx plus b. Answer. And again, you're welcome to check it if you'd like. All right, I'm going to go back up to the 2 I skipped, starting with 33. So this one, you may look at it and you're like, ooh, do we need to use quotient rule? No, you don't have to. So let's rewrite this problem as y equals, see this negative, put it on top, otherwise it'll get lost. Negative 1 over, isn't this just x squared minus 9 to the first, right? We don't usually write to the first, but it's there. And then let's bring that back upstairs. So that was really negative and it got sent down. So our function is negative 1, x squared minus 9, all raised to the negative 1. That is just the function, the y, rewritten. Let's now do the derivative. Multiply, so that's 1. Keep the garbage in the parentheses, subtract 1. times chain rule, the derivative of the parenthesis. So the derivative of x squared is 2x. The derivative of negative 9 is nothing. We can do 1 times 2x. So that is 2x, and then that parenthesis drops down, and then send it to the bottom because it'll look better. So we have 2x over x squared minus 9 squared. That is our derivative. If you know quotient rule, we could have done quotient rule. And actually, maybe I'll do it that way in a second. But this was probably easier to rewrite it, to bring that guy upstairs and then go. All right, now we want the slope. I mean, the green pen to the left. We're going to do y prime evaluated at our x value 1. So that's going to be 2 times 1 over 1 squared minus 9 squared. So that's 2 over 1 minus 9, so negative 8 squared. That's 2 over 64, which reduces to 1 over 32. There's the slope. If they just were asking for that, you'd be done. But we want the equation. Y equals mx plus b. Looks like our y is an eighth. Our slope is 1/32. Our x is 1, and b. I'm going to come here for room. 1/8 equals 1/32 plus b. We could just times this by 4, so that's 4/32. Again, if you're using fraction calculator, you don't really need to do that step. But it's not that hard. If you're in calculus, you can do this fraction stuff, I promise. There's our b of 3 over 32. Final answer, y equals m. Oh, wrong thing. Y equals mx plus b. That's 33. And that was using the method of just bringing it up. I will now do the same one. So if you don't want to see this, fast forward until you see me working 34, until you see 33 covered and 34 uncovered. I will now do the same one doing quotient rule. Okay. I'm still going to move that negative to the top. I just never like a negative on the side. It's too easy to forget. So move that to the top. Quotient rule. To take a derivative of a fraction, which is what we have, we use the quotient rule. And if you let your function, your y, be f over g, right? Quotient rule says this: g f prime minus f g prime all over g square. Some teachers make a little rhyme and they go low d high minus high d low over low square. So if your teacher says that, and it kind of sounds like the Hi-Ho song off of Snow White, hi-ho, hi-ho, I don't know. I don't particularly love the little saying. I just remember the rule. But you do whatever works for you. Okay? I like to do side work on this. What I mean by side work is I literally draw a section on my paper and I call it side work. And I just separate it off because it's not actually part of the problem, but it's some work I need to do the problem. So the top function is f. So the top of our fraction is -1. What's the derivative of that? Nothing. The bottom function is g, x squared minus 9. What's the derivative of that? 2x. That is our side work. Now we can actually do y prime. Following quotient rule, it says g f prime. So if you set up your side work like this, g f prime, it'll always be like diagonal. So that's going to be -1 times 2x minus, that's the rule, f g prime. So that's the other diagonal. 0 times x squared minus 9 all over g squared. So that's the original bottom, the whole thing, squared. Okay. Alrighty. So anything times 0 is gone. And we are left with y prime is -2x over x squared minus 9 squared. But that is not what we had. We just had regular 2x when we did it. Hold on. Let me do it the other way real fast. When I brought this up a second ago, it looked like this. And then we took the derivative, which was 1, kept that there, subtracted 1 times 2x. Huh. So this is not gonna, I made a mistake in either one way or the other, and I don't think I made a mistake in the first one. Because this would just be 2x over x squared minus 9 squared. That is so weird. I don't see my mistake. Oh, I see my mistake. I did the quotient rule the wrong way. I'm sorry. It's approaching 10 o'clock here for me. My bad. Okay, let's work that quotient rule again. Look at my red formula. GF prime. I went the wrong way. GF prime. This should come first. So 0 x squared minus 9 minus, because that's in the formula, and then FG prime. There we go. Negative 1 times 2x over the original basement squared. Okay, now let's simplify this. So this is y prime. 0 times anything is 0. Minus minus is plus 1 times 2x. Who cares about 0? Who cares about a 1? This top is just 2x and the bottom's fine. There we go. There's the derivative. That matches what we had before. Just didn't do my quotient rule right. And now that's the derivative, and then you would proceed as normal from there. So the slope would be that derivative at 1. We already did that. That was 2 times 1 over 1 squared minus 9 squared. That came out as 2 over 64, reduced to 1 over 32. And then we did y equals mx plus b, and that was an eighth equals a 32nd times 1 plus b. Solve, 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 and b came out as 3/32, giving us a final tangent line of 1 over 32x plus 3 over 32. That's using quotient rule once I got the quotient rule in the right order. Woo! 34. Last one. Okay, this one, we could technically bring the stuff up. But if you look at the difference here, because this was just a 1 and really a negative 1, bringing it up like we did in the first method was pretty valid and pretty easy. Because there is other garbage, and again, technically negative, you could bring this up. But because it's not just a 1 up there, it's an x squared, or technically a negative x squared, it's not going to be as fun to deal with. So I probably would not bring this one up. I would probably just go to the quotient rule, which I'm going to get right this time. Let me write that quotient rule. I actually write quotient rule every time I use it because I want to have that rule there to remember and to hopefully do right. So again, quotient rule is the bottom, G, the top prime minus the top bottom prime over bottom squared, where your function is f over g. Okay, side work. Again, scribble that negative out, put it on the top, otherwise it'll get lost. The top is f, so negative x squared, take the derivative, that would be negative 2x. The bottom is g, take the derivative, which would be 4. Okay, now we're ready. I'm going to do the quotient rule right this time. Y prime, G, F prime. So that's 4 times negative x squared minus, because that's the rule, F. Did I just do this the wrong way again? G, F prime. Yep. Oh my goodness. Losing my mind. Here we go. Try that again. Y prime. GF prime. There we go. Negative 2x times 4x minus 4 minus FG prime. There we go. 4 times negative x squared all over the original bottom squared. Okay, let's just fix this. Distributing would be negative 8x squared, positive 8x, positive 4x squared. That's just the top. Combined like terms, we're looking at negative 4x squared plus 8x all over the bottom there. That's the derivative, I hope. Pause me because I'm about to erase. Okay. Let's now get the slope. So we're doing y prime, which is that in the green box, at negative 1. So everywhere we see an x, put in a negative 1. Okay, on the top, we'd have negative 4 times 1 minus 8. So that's negative 12. On the bottom, we'd have negative 4 minus 4 squared. Negative 8 squared is 64. You can divide by 4 to simplify to negative 3/8. Okay, but I did this problem before and I thought it was positive 3/8. 1 second, I'll bring this all back. Ignore me for just 1 second. No, I think it's okay. I think it's okay. I don't see a mistake. Hold on. Wait, maybe I do see a mistake. Hmm. I feel like it was positive, but I don't see a mistake anywhere. Okay, I'm going to start this problem over. It's been a nightmare, hasn't it? One more time. Sorry. Put that negative to the top. It's fine. Okay. Quotient rule. GF prime minus FG prime over G squared. Side work. F is the top. F prime would be negative 2x. G is the bottom. G prime would be 4. Okay, G F prime. So negative 2x, 4x minus 4, minus F G prime over original bottom squared. Yeah, that would be negative 8x squared, positive 8x, positive 4x squared. And then, yeah, I got the same thing. Sorry. Combined like terms would be negative 4x squared plus 8x. Okay, inserting negative 1. So negative 4, negative 1 squared plus 8 times negative 1. So that's negative 4 minus 8. That's negative 12. And on the bottom, that would be 4 times negative 1 minus 4 squared. So that's negative 4 minus 4, so that's negative 8 squared, which is 64. Divide by 4, and we get the slope is negative 3/8. All right, I'll definitely check this one, but let's run with that. So y equals mx plus b. So that'd be negative 3/8 times negative 1 equals an eighth plus b. So 1/8 equals 3/8 plus b. I don't think that's right. Minus 3/8, so you'd get negative 2/8 equals b, and then that would reduce to negative fourth. So y equals negative 3/8 x minus a fourth. Again, I did that problem before, and I don't think that's what I got. So I think I'm slipping a sign somewhere. See, math will humble you. It's okay. It is okay to struggle. We will get there. And this might be right. I don't know. I'm going to just look on my phone. The original question. That's why I saved this one for last. Should be able to get it though. The original thing was y equals negative x squared over 4x minus 4. The point of interest was negative 1, comma, an eighth. The answer we just got was y equals negative 3/8 x minus a fourth. It's hard to tell. Where's our point of interest, I guess? Yeah, that looks like he hits. Hmm. So my student's teacher here actually provided the prime because this particular student hasn't learned quotient rule yet. So that's what the teacher got for the prime. Now mine is slightly different because the teacher factored the top. We could pull out a 4x, which would leave negative x plus 2. And that's still not what the teacher has. Hmm. I mean, am I blind? That negative is there, right? Give me one. Ignore me for a second. What if I just plug in this into the function? So negative, so that would be 1 over negative 8. So that would be negative, negative. Yeah, no, that's fine. Okay. Yeah, give me one second. I'm going to pause the recording. Be right back. All right. I'm back. I know what I did. I messed up some fractions a long time ago. So my derivative should have been right. Okay. So over here in the dark green, that derivative is fine. That negative 4x squared plus 8x and then the bottom, it's fine. That is the derivative. I messed up when I plugged in the value of x. So bear with, bear with. So we are redoing y prime evaluated at negative 1. So that's negative 4 times negative 1 squared plus 8 times negative 1 all over 4 times negative 1 minus 4 squared. So on the top, we get negative 4 times 1 minus 8. So that's negative 12. On the bottom, we get negative 4 minus 4 squared, which is negative 8 squared, which is 64. This is where I've messed up. We need to divide by 4, divide by 4. This is negative 3/16. I kept saying it was negative 3/8. So from this point, the problem is wrong. But now I am fixing it. That is the slope. Y equals mx plus b. That is our m, x, don't know b, y. Okay. So that's 3/16 because negative, negative. Let's change this to 2/16. Don't though, if you're using a fraction calculator, you don't need to do that. 2 minus 3 is negative 1/16 is b. Y equals negative 3 over 16x plus a 16th. Answer. I was simply making a fraction mistake. Silly, silly. And now that should be fine, and it looks fine. All right, let me take that back to Desmos just with the answer. So that was negative 3/16, and then it came out as negative 1/16. That looks so much better. Yeah, that looks more tangent to the point of interest. Where is our point of interest? Let's label it. There he is. That looks so much better. Let me take it back to the wrong answer. See how it goes through that? We're not really supposed to go through that. We're supposed to just barely graze it. That's what tangent means. You're going to touch it just right at that point. Boom, that's so much better. Good. All right, apologies for just silly fraction mistake, but life, and we fixed it. I hope this was helpful, except for maybe the last one, and that you're feeling good with finding the tangent lines to the function at given points. Have a good day. Bye-bye.